This is S. Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. In this lecture, we are going to discuss addressing modes. So, the addressing modes. The term addressing modes, it refers to the way in which the operand of an instruction is specified. So, addressing mode is the way in which the operand of an instruction is specified. That is called addressing mode. So, if you consider any instruction, the instruction basically it is having two fields. The first field is the opcode field, and then it is followed by operand. So opcode field and operand. So opcode. So what is opcode? So opcode is, it specifies the operation to be performed. So the opcode. So opcode is a short form of operational code. So it specifies what type of operation to be performed. So that is called opcode. And second one, operand. So operand is the data or memory location used to execute that instruction. Okay. So operand is the data or memory location on which we are performing the operation. That is called operand. Okay. So this operation must be executed on some data stored in computer registers or memory words. So these operands, sometimes these operands may be direct operands, or sometimes we are storing in registers, and sometimes we are storing in the memory words. Okay, so these are the operand. So opcode means operational code, and operand is the data or memory word on which we are performing the operation. So that is called, by combining this opcode and operand, so we can call a instruction. So instruction means it is a command to the processor in order to perform some task. So that is called instruction. So here this addressing mode. So this addressing mode, it specifies the way in which the operand of the instruction is specified. So the memory address of an operand consists of two components. So first one is a starting address of the memory segment, and the second one is a effective address or offset. Effective address or offset. So an offset is determined by adding any combination of three address elements. So effective address is the address by combining any three addresses, that are displacement, base, displacement address, base address, and index address. So what is displacement? So displacement is an 8-bit or 16-bit immediate value given in the instruction. So that is called displacement. And base. So the contents of the base register, BX or BP. So here, as a base register, we can use any of these two registers. Either we can use BX register or we can use BP register. And index register. The contents of index registers are SI or DI. So SI means source index and DI means destination index. So the memory address of an operand. The memory address of an operand basically consists of these two addresses. One is the starting address, and the second one is the effective address. Again, the effective address is calculated using three addresses, that are displacement, base and index. So these addressing modes we can understand clearly with one general example. That is, I need to pay money to my friend. Okay, so in what ways I can give? So either I can give direct cash to my friend, or I can do an online transfer, or I can give a check to my friend, or I can pay through UPI. So these are all the different payment methods. Similarly, here also addressing modes. Addressing mode. That means the way in which the operand we are specifying. So that is called addressing mode. So here different types of addressing modes are there. Okay. So although the most addressing modes, it specifies the address field of an instruction. There are two modes that need no address field at all. So two modes it doesn't have any address field. Okay. So the two modes are implied addressing mode and immediate addressing mode. So these two it doesn't have any address field. Okay. So first one is a implied addressing mode. What is implied addressing mode? In implied addressing mode, the operand is specified in the instruction itself. Okay, so that means here the operand is specified along with the instruction. That is called implied addressing mode. So in this mode, the data is 8-bit or 16-bit long, and data is part of instruction. And zero address instruction are designed with implied addressing mode. So this type of instructions are called zero address instruction. That means here there is no address part is specified. Okay. So operand is specified in the instruction itself. So this is called implied addressing mode. So examples are CLA, CMA. So clear CLA. What is CLA? Clear accumulator. Clear the accumulator. So clear is nothing but the accumulator is loaded with zeros. So that is called clear accumulator. So that means here the default register is the accumulator. So here we are not specifying any address field. So that's why it is called implied addressing mode. And second example is the CMA, complement accumulator. So complement means not operation, reverse operation. So whatever the contents are there in the accumulator, that will be complemented. So that is a complement accumulator. So this is a immediate addressing mode. So in immediate addressing mode, we are not specifying any address field. So the operand is specified in the instruction itself. And coming to the second one, that is immediate addressing mode. Immediate addressing mode. So in this immediate addressing mode, the data present in address field of an instruction. The data is present in address field of the instruction. So this is an instruction format. So first field is a opcode field and the second one is the address field. So in this address field, we are specifying the data. Data is nothing but operand. Okay, so this is a the type of data is a immediate data. Immediate data. So we are specifying immediate data. So designed like one address instruction format. So this type of instructions can be classified as one address, one byte address. And coming to the note, limitation in the immediate addressing mode is that the range of constants are restricted by the size of the address field. So here in the address field, we can specify the constant values, but that constant value, it is limited by the size of the address field. So that is a limitation here. And example, move AL comma hash 35. Move AL comma hash 35. So this is a immediate addressing mode. That means here 35. What is this 35? 35 is an immediate value, immediate operand. So immediate operand, and the immediate values are prefixed by hash symbol. So if hash is there, it represents that immediate data. Okay. So here the 35 is copied to the register AL. So we are copying this 35 into the register AL register. Okay. So this is a immediate addressing mode. So it is a before the data, before the immediate data, we are specifying the symbol hash. Okay, and coming to the next type of addressing modes, it was mentioned previously that the address field of an instruction may specify either the memory word or the processor register. Okay, so the operand we can specify either in the processor register or in the memory word. So when the address field specifies the processor register, the instruction is said to be in the register mode. Okay, so in the so already we know the instruction is having two fields. One is opcode, and another one is the operand or address field. Okay, so if a register is specified in this address field, then that type of addressing mode is called register direct addressing mode. So register direct addressing mode means so the operand is specified in the register. So example, move AX comma CX. So here the contents of CX register we are copying to the register AX. So that means here the operand is specified in the register. That is nothing but CX register. So that's why this type of addressing mode is called register direct addressing mode. And coming to the register indirect addressing mode. So in this addressing mode, the operand's offset is placed in any one of the register BX, BP, SI or DI as specified in the instruction. Okay, so the effective address of the data is in the base register or an index register that is specified by the instruction. So you can see here two register reference is required to access the data. Two references are required. So example, move AX comma offset of BX. So here that means move the contents of memory locations addressed by the register BX to the register AX. So for understanding this, let us assume the AX contents are 0005 and BX contents are 4001. Okay, 4001. So here the BX register, So BX value is in BX register we have stored 4001. 4001. So this is not the address of the operand. So 4001, it is not the address of the operand. It is the address of the memory location that contains the operand. So in 4001, what is the data present? 4004. So this is a data present. So using this address, so this is the address. So this is address. So it will go to the 400 location. In that, what is the value? 4. In that, the value is a 4. So this 4, we are moving to the AX register. Okay. So that means here, the BX register is used to store the address. But here, we are not specifying the direct address. We are giving a indirect address. So what is the actual address of the operand? Actual address of the operand is 4004. But in the BX register, we have given 4001. We have given 4001. So in this 4001 location, it contains the address of the operand. Okay, so that is called register indirect mode. That means here the address of the operand we have given in indirect way. So that's why it is called register indirect addressing mode. And next one, auto increment mode. Auto increment. So the effective address of the operand is the contents of a register specified by the instruction. After accessing the operand, the contents of this register are automatically incremented to point to the next consecutive memory location. So here you can see the example: add R1 comma R suffix auto. So we have assumed one another register, that is the name of the register is a auto register. Okay, and here we are specifying a plus symbol. So this plus symbol it specifies auto increment. Okay, so you can understand with the diagram. So this is a opcode and this is a register. Okay, so in this register, the effective address of the operand is the contents of the register specified. Okay, so in this register, it has stored the effective address of the operand. Effective address of the operand is stored in the register. Okay, so in register R auto, what is the value? 100. Okay, so what is 100? 100 is the effective address of the operand. So that means in the 100th memory location we have the operand. Okay, so it is pointing out to 100. So in 100 location, so we have the operand. So the CPU can access that operand, and after accessing the operand, the contents of the register are automatically incremented to point out to the next consecutive memory location. Okay, so we have access to the operand which is present in the location 100 location. So after accessing, its address will be incremented. Its address will be incremented to point out to the next consecutive memory location. So what is the next consecutive memory location? 101. 101 is the next consecutive memory location. So it will be incremented. Okay, so this is called auto increment. So that means automatically its address is incremented to the next consecutive memory location. So that's why it is called auto increment mode. Similarly, auto decrement mode. Auto decrement. So the effective address of the operand is the contents of register specified in the instruction. So that means the register which is specified in the address field that contains the effective address of the operand. So here in this scenario, 100 is the effective address. 100 is the effective address. So it will point out to the 100 location. Okay. Then okay. So here before accessing the operand, the content of this register decremented to point out to the previous consecutive memory location. So its auto decrementer, it is represented with symbol minus. So we have represented minus before the register. So that indicates that auto decrementer. So when auto decrementing takes place before accessing the operand. So where is our operand? Okay. So before accessing the operand, the contents of the register are automatically decremented. So the actual effective address is 100. So it will point out to the 100. After that, it will be decremented by 1. So it will become 99. And then whatever the operand is there in that location, that will be accessed. So that is a auto decrement mode. Now coming to the direct addressing mode. So in this direct addressing mode, the instruction includes a memory address. So the memory address is given as part of the instruction. So that is called direct addressing mode. That means the address of the operand is given directly in the instruction. So that's why it is called direct addressing mode. So the CPU access that location in memory. So example, LDAC 5. LDAC 5. Okay. So the CPU, it reads the data from memory location 5 and stores the data in the CPU's accumulator. Okay. So LDAC 5. So this 5 is it is a direct address. It is a address of the operand. So this 5 is given in address field. And the opcode is the LDAC. LD means load. AC, accumulator. That means load accumulator. Load the accumulator with the contents of the memory whose address is specified directly. Okay. So that means here the address is 5. Let us assume the memory locations are 4, 5, 6, 7. So now this is a address of the memory location. Address of the memory location. So what is the address specified in the instruction? 5. So it will point out to the 5th memory location. So here we have a operand. That operand we are copying to the register accumulator. So that is called direct addressing mode. So that means the address of the operand is given in the instruction directly. And coming to the indirect addressing mode. Indirect addressing mode. So indirect addressing mode, the address specified in the instruction is not the address of the operand. So it is the address of the memory location that contains the address of the operand. Okay, so see here. So example, LDAC @4001. So the address we can specify with the @ symbol, or we can specify directly 4001. Okay. So here address. What is the address here? 4001. But this is not the effective address of the operand. It is the address of the memory location that contains the operand. So it is the address of the memory location that contains the address of the operand. Okay. So here what is the address specified here? 4001. So it will point out to the 4001 location in the memory. So in that it contains some address 4003. So 4001 is not the effective address of the operand. That is only 4001 is the address of the memory location that contains the address of the operand. So the actual operand is stored in the 4003. Actual operand is stored at 4003. So that address is given in an indirect way. So that's why it is called indirect addressing mode. Indirect addressing mode. Okay. So see here. So in 4003 we have a operand. So that operand we are copying to the accumulator. So that is called load accumulator. And coming to the relative mode. Relative mode. So in this relative mode, the operand supplied is an offset. So offset is nothing but it is a group of 2 or more addresses, not the actual address. So it is added to the contents of CPU's program counter register to generate the required address. So we need to calculate the effective address here using the offset address. So how we can calculate the effective address? By adding the value of program counter with the address part of the instruction. So what is the instruction given? This is the instruction given, LDAC some dollar symbol 5. So this dollar symbol is used to specify the address. We can use either @ symbol or this dollar symbol. Either way we can use it. So 5. What is the address given in the address field? 5. So this is a 5. What is the contents of the program counter? So see here. So example, LDAC 5 is located at memory location 10. So this instruction, it is located at the 10th location. So this is a, okay. So we have a memory. So this is 10, 11. So at 10th location, what is the instruction? LDAC 5. So if this instruction is executing, the address of the next instruction, it is stored in the program counter. So that means the program counter address is 11. So the program counter address is 11. Okay. The program counter address is and it takes 2 memory locations. So that means this LDAC instruction, it occupies 2 memory locations. That means 10 and 11, it is occupied by the LDAC 5. So the next instruction will be available at the 12th location. So this address will be stored in program counter. So now the program counter address is 12. So this LDAC 5, it takes 2 bytes of memory location. So that's why 10th and 11th memory locations are occupied by the LDAC instruction. So that means next instruction starts from 12th. So that's why the program counter, it has stored 12 in the program counter. And the address given directly in the instruction is 5. So we are adding these 2 addresses. So 12 plus 5. So it results 17. So what is the 17? 17 is the effective address. 17 is the effective address of the operand. So that means in the 17th location, we have the operand. So that operand we are copying to the accumulator. Okay, so this is a relative addressing mode. And coming to the index mode. Okay, so already we have seen the index mode works like a relative mode. So already in previous slide we have seen about the relative mode. So in relative mode, the effective address is calculated by adding the contents of the program counter with the address specified in the instruction. So this index and relative address mode both are same, except the address supplied by the instruction is added to the contents of the index register. So previously we have used a program counter, but in this index addressing mode we are using a index register instead of the program. So the effective address, it is calculated using the base address, index register. So effective address is calculated using the base address and the index register. Okay, so instruction is a LDAC 5. Okay, so the index register. So this is an index register and this is the address. So address is given 5 and the index register. So the instruction reads data from the location 15 and store it in accumulator. So see here, if the index register, so the index register value is 10. Index register value is given directly. So index register value is 10 and address is 5. So total 10 plus 5. So 10 plus 5, 15. So 15 is a effective address. So from the 15th location, we have a operand that will be copied to the accumulator. So that is a index addressing mode. And next one is a base register addressing mode. So this base register addressing mode, it is exactly the same as index mode, except the index register is replaced by the base address register. So this is similar to the previous one, index addressing mode. but only the difference is instead of the index register, here we are using a base address register. That only different. The remaining is same. If the base address register contains the value 10, so here the base address register, it contains the value 10. So the base register is 10 and address is 5. So 15. So from the 15th, it will copy a operand and it will be copied to the accumulator. So the instruction, it reads data from the location 5 plus 10, 15 and store it in accumulator. Okay. So this is about the base register addressing mode. So in this lecture, we have discussed what is addressing mode and different types of addressing mode. So we have discussed in detail about each addressing mode with examples. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.